So welcome everyone. And I'm very happy to be here, even if the crowd is kind of a little bit small, but that doesn't matter. And I'm very happy to be here. I want to thank all the Factor team that is behind the Learning Fest. So this is a great opportunity for me and for everyone to know a lot more about Factor, and maybe why not, maybe in the future you join Factor as well. So as Berto mentioned, this is a talk about Dagster. So the title is a little bit strange. Maybe it wasn't a good choice, but the title is Dagster the Prince that was promised. I wanted to give some kind of a legendary thing to the talk, but that doesn't matter. And so the agenda for today. First of all, I would like to tell you why you should attend this meeting. That's very important to know. A little bit about myself, and after that, we will see what Dagster is. I will give you a small example about Dagster capabilities, how it is different from other tools, mainly Airflow, and why you should give it a try. And as Berto mentioned, at the end we will have a Q&A section. So why should you be here? So today we are going to dig into an ongoing battle for the throne of data orchestration. If we see this kind of an epic battle between Airflow, that is the king, and Dagster, that is the new one that wants to kind of conquer the data engineer arena. So that's what we are going to see today. A little bit about me. So I'm here in Colombia. If you see the map, so Colombia, as you may know, is at the north of South America. I live very close to Bogota, the capital city of Colombia. At the north of Bogota, there is a town called Cajicá, a very small one, where I live. A little bit more about myself. If I define myself through my hobbies, you can call me, let's say, a chess player, a hiker, a cyclist, an actor, maybe. But above everything else, I'm a Python developer. So I have been working with Python since 2016. In a variety of different projects like software development, a little bit of artificial intelligence, machine learning, data science, data analytics. And in the recent years, I have focused my career on data engineering. Even though my bachelor is as an electronics engineer, I had to switch my path a little bit in my career because, maybe it's more powerful to be a data engineer than an electronics, principally in Colombia. Tomorrow, I will talk about more about how I landed as a data engineer. So if you are interested in that section, you are very pleased to join tomorrow in my another talk about task. So today we are going to talk about Dagster. So what it is Dagster? Dagster is an orchestration platform. If you have worked before with an orchestration platform, you see that that is just kind of a tool that allows you to write recipes for your processors. So you can write a recipe with the steps and define some dependencies between those steps, in which order those steps are going to run to achieve something. So if we focus those processes in data, you build data applications. What Dagster says is that actually there is not too many tools that are a good fit for data applications. So they want to be that fit. So they offer themselves as a next generation data orchestrator, and they are competing against Airflow because, as you may know, Airflow is the industry standard. So everyone is using Airflow for data applications, even though there are some regards, some challenges when using Airflow for data applications. Everyone seems to like using Airflow. What they want to address, so Dagster wants to focus on the engineer, so to give the engineer a tool where he can develop and test easily his data applications. And after everything is developed and tested, you can deploy and execute easily as well with Dagster. And after everything is running in production, you'll have a tool to monitor and observe. Very similar to Airflow, but with some differences and some enhancements from my point of view. So how Dagster does it. So Dagster, since it's data oriented, the idea of Dagster is to exchange data between the nodes. So each step in the recipe will exchange some data between. Another advantage of using Dagster is that they have a lot of focus in the metadata. So that means that for the data that you are kind of exchanging between your nodes, it generates some metadata like we are going to see in the examples. So you have a richer URI because the code that you are writing uh, also meet the purpose to get documentation in the UAI, so everyone kind of can have a very good understanding on how your pipeline is working. Another concept very interesting in Dagster is that they want to decouple the topics in your application. So you have the compute in a function, and you can reuse that function, and you have resources decoupled from that, so you can interchangeably change the resources. So let's say you have a resource for testing, you have a resource for staging, and you have a resource for production, so you can decouple easily those things, as well as the storage. So maybe if you run sometimes your pipeline, you want to store in your file system, but changing a parameter you want to store in S3 bucket, and so on. And the testing is a very important here. So if you have worked with Airflow, so sometimes the testing is not as easy as it can be. So with Dagster is a little bit easier. And there is some main concepts here in Dagster that I want to show you first before going into the examples. So the main one is the OPS. So an OPS, that stands for operation, is just a single unit of computation. It's just a function. A graph, what is a graph? A graph is just a bunch of ops putting it up together. So you build a graph, and the same for the job. So you can put a set of graphs and ops and together and build a job. And you have the repositories. Let's say you have several teams in your company, a team for data science, another for machine learning, and another for data engineering. And maybe some jobs, some of your recipes are more related with some data engineering process, but another is just to build a machine learning model. So you have two repositories, one for the data engineering side, another for the machine learning, and so on. It's similar to the DAGBacks from Airflow. So you have an idea, and as well the resources. So as I mentioned, a resource can be an external dependency, a database, an API endpoint. Each API endpoint can have different API keys, so yeah, and so on. So I hope you know the jargon. And with this, we can see a quick example. So let me go to the example. So in here, I'm going to use a fictional character named Pip. So Pip is a fictional character from a book called Great Expectation that I like to use because I really like the story of Pip. And so I like the analogy of Pip having kind of a hard life as we data engineers do. And so in here today, we are going to see the journey of Pip discovering Dagster. So Pip is a new data engineer, so his manager is kind of asking to Pip to go. Sorry, I'm in the wrong one, and this is the first one. He receives a request from his manager that is very simple. He wants just to have a pipeline where he downloads some data from an API, in this case, this one. And after he has the data, he wants to get some insights from the data. So he's very, very careful and very knowledgeable. And he goes and write this function here. It's very easy Python code, very straightforward, nothing strange. Everything is kind of the usual Python code, as you may see everywhere. This data is a data set, a small data set, very simple. Actually, it's just a list of cereals with some values for some nutritional things. And we are going to try to get some insights from here. So what pip does is create this another function to just find the highest whatever, whatever I mean, whatever metric. So let's say if I want to know the cereal with the most caloric take. So I'm going to use this function. I'm going to sort the serials and get the highest one, and so on. So I'm not going into the details of the code. It's very straightforward. So you can run like this. So he goes and put calories. He download the data and he use the metric calories. So if he goes and run this Python script, it's very easy because he runs, downloads the data and runs the two functions, and you get that the most calorie, the highest amount of calories is for the strawberry. So you don't want to eat that because it has too many calories. So Pip is very happy because he has achieved what his manager requests. But now he thinks in the future, what happens if, let's say, I want to download from other kind of sources of maybe I don't want to find the highest, but I want to have another kind of metrics, another kind of statistics. So this source code is going to continue growing and growing and growing, and maybe at the end that will put the mental health of people at risk. So he don't want that. So he asked some data engineers at Factor, and they kind of say, Pip, why don't you use an orchestrator? There are several orchestrators. Why don't you try Dagster, for example? So he goes and they download Dagster using Pip. So it's very easy. He is, if you notice, is the same code as before. The only thing that he needs to change is to add this operation here that stands for the OP, as I mentioned previously. So now these are not just Python functions, but now are Dagster operators. But it's the same. In here now, a job, remember that is just a bunch of ops putting it together. So I'm doing the right that same thing here. So I'm going to put the output of this function as an input from this. And if you notice here, I'm not putting this metric in here. For Dagster, that will mean that I'm going to use this metric as a configuration input. So when I'm going to run this job, I'm going to use this configuration just to tell Dagster that for metric, that is not the output of a previous operation. We are going to use this value as configuration, calories in this case. So Pip is very happy because he can go and run this again. So he goes to the terminal and run the step 2, and he sees a lot of jargon here, a lot of things that are not very important, but at the end he sees the same output as before. So Pip thinks, but what is the new thing here? So what Pip is missing is that now he has access to the Dagit. What is Dagit? Dagit is the UI of Dagster. So if you run this and go to this port, I already did that, and you will see the UI from Dagster. So it's very nice, it's very clean. It has a lot of information. He can see here the operations, the flow of the data, what it does, but he sees that it kind of seems to be very incomplete. Maybe something is missing here. However, he goes and see here the launchpad where he can put the configuration from calories, and he run here. So, oops, he click run, and he sees the run. So this is a previous run that I did. So a lot of information here on how the pipeline has run. So a lot of more information that maybe you will see in Airflow, for example, but it can be a lot more. So Pip wants to put more information here, not only to see just these boxes here, but more metadata. So he goes back, he goes to the step 3, and now what is different here is that he has the same, but he wants to add metadata. So one of the main metadata that you can put on are the doc strings and the type hints. This is not, I mean, if you are not using an orchestrator, for example, but you are using writing Python code in general, I encourage you to make your functions readable and put doc strings there and put type annotation. It's a very good practice that I recommend to you. That will make your life easier. Your future self will be happy because he won't spend time debugging, and your coworkers will be all happy as well. So yeah, he puts those doc strings. So he can see this in the UI I will show you. He can put another kind of metadata here. So he wants that return function has a name, so serial name, but even more, he wants also to put this metadata here. So this nice one to get the output with this message. If let's say you have another case, for example, that you are not just calculating this metric here, but generating a report, for example, you can put here the link of that report and put that metadata into the UI. Or for example, you can put more metadata about your data set. Let's say here, for example, we are kind of checking how many rows we download. Let's say if one morning you kind of wake up and see that everything fails, so you have something to check. If let's say for some reason your download fail, you can see here, oh, the length of this counting is 0. So that's the problem, and you can debug easier and faster. So he do the same, and now he goes to the UI to see what is the difference with the metadata. So he see that now it's clear here. So everyone that wants to know how your function and your pipelines behave and works have an easy panel to go and see without digging into the code. So if maybe they are just a product owner or something and they don't know how to use Python or something like that, you can give them this URL and they can go and run and debug and test and run. So yeah, that's great. He goes and he wants to know more about Dagster, so he keeps researching. And after that, he sees that, okay, maybe I do need to run this every day. I do not want to wake up early and run this manually. So he put Dagster in charge of that. In order to do that, the only thing that he needs to do is create a schedule. How do you create a schedule? You use this dates decorator, you assign the job to that decorator, and you return the configuration that you want for run on a schedule. Also, this cron schedule will it means that it's going to run in this case every 5 minutes if I turn on. So he add this schedule, and the code is the same as before. Now he wants to have this organized in a repository, so he put the decorator here, returns a list on this function with the jobs and the schedules. So he have this in a single place, this repository, and he goes and do the same. So the code will be the same except for the schedule. And now a difference here that you can notice is that in here, if you see my mouse where I'm pointing out, in the new one, there is a schedule that I can run every 5 minutes, so I can turn on this, and then this is going to run. I have a warning here because I haven't activated the daemon for this. So the daemon is kind of the heartbeat of Dagster. So it's something that is running in the background every few seconds to check if something needs to run. So you can run that with this command right here, that git daemon run. I will show you in the next example how that works. So that's the first example that I wanted to show you. After this simple example, you can see and compare with Airflow already if you have worked with Airflow before. So you can see that a job in Dagster is very similar to what a tag is in Airflow. An operation is very similar to a task. Dagster claim that they don't have operator, but actually I don't agree with that, because the functions that they import from third parties are the same as in Airflow. For example, in Airflow, you just do from Airflow import Snowflake operator or something like that. Is something similar that you do in Dagster. So it's kind of, they're different because are decorator, not just functions that you are more limited, but they are kind of operators. Also, you have graphs, task groups, resources are very similar to the hooks, and the XCOMs and the IO manager. Actually, I forgot to show you the IO manager, so let me go back and show you the IO manager, what an IO manager is. Let's say if you remember, one of the concepts of Dagster is the decoupling. So you want to decouple your compute from their storage, for example. So you can write this IO manager so in a way when you run a function, an operator, and you define an IO manager like this, the output, this return, will be handled in some way. In this case, it's going to go to this IO manager, and what it's going to do is that when it's an output, it's going to take the data frame from that object, from that return. In this case, it's going to be serial. So serial will be the object here. It's going to convert it as a pandas data frame. And with pandas, we are going to write that into the file system as CSV. So it's something that you don't need to alter your compute. You don't need to put in here a lot of lines of code, kind of breaking the principle that says that a function only does one thing. But you have your function here, very nice, very nice here, Python code that does only one thing, that is getting the data. And you have a separation of purpose here with the IO manager, in a way that if you want to, let's say in the future, you want to change this, instead of writing a CSV, you want to write a Parquet file or something, you don't need to change your compute, and your main logic will be the same. The same for the input. If I'm using this IO manager for input, what it's going to do is to read the CSV file from the file system using pandas. So that's what I was missing to talk about the IO manager. And Airflow has something very similar, that is XComs. However, if you have been working with Airflow for a few years, you will know that maybe 2 years ago, 1 year ago, and was one of the main critiques that Dagster did, is that even though with XComs you are available to pass data between your between your tasks, sorry, actually Airflow doesn't encourage you to do that, because they say, okay, we are an orchestrator, but we don't want you to kind of interchange data between tasks, because that is kind of messy. Don't use that. And XComs has many limitations depending on the backend that you're using. So maybe you can't exchange big data between your nodes, between your tasks. However, today, if you see, XComs has new backends. So you are able to, as I show you in Dagster, that we are kind of putting data in the file system as CSV file. You can do the same with XComs, even putting files into an S3 bucket, a database, and a Snowflake. So you can play with the XComs with a lot more flexibility than before. Maybe not too much flexibility as you may see in an IO manager, but it's kind of similar. So today, Airflow, and that's one of my conclusions, Airflow keeps evolving and becoming more data aware. So we will see more in more newer version of Airflow kind of being more data aware as the time goes by. So yeah, something to take into account. And is in this same direction, when I was writing this presentation, I must say that I had an interesting perception of the new documentation of Dagster, because in previous years, maybe they mentioned the assets. Assets are another feature of Dagster. Maybe in the past, they kind of letting these assets to the end, but now are the main point in the Dagster framework, because they want to work mainly with assets. What an asset is in a data application, an asset is a data set, because a data set is what it makes your product valuable, right? So a data set can be in a table, in a file, in a model. And when you say that an asset is software defined, is because you are associated and a function, an operator with a data set. So you will have a function, an operator in Dagster that produce a data set, and that will be called a software defined asset. However, Airflow has a response for this as well. And now they have the data sets. So it's very similar to that. So with data set, you can trigger a DAG, not on a schedule, but in a change on a data set. So yeah, that's very good. I'm going to show you a more complete example of Dagster with more features. This I have taken this example from the official documentation, so you can as well go there and download that and start playing with it. So let's see that example here. So yeah, in here, you will see that we are going to see this feature from Dagster, the software-defined assets, the schedulers, the sensors, the IO manager, the resources. I have already mentioned some of them. Maybe the sensor is not. The sensor is just a function that is running with the daemon. Remember the daemon, and we'll check if something has changed, and with that is going to trigger something. So it's what you need to know. What else? It's easier if I show you right here the project. So this is the project. In here we have this global asset lineage. What it is just kind of the dependencies between assets. So remember that an asset is just data sets associated with an operation. So for example, this asset is the main one. This is going to run a function every hour because I have defined it partitions. So in Dagster, you have partitions. That means that, for example, if I establish a partition for an hour, uh, my process is going to run each hour and I can rerun and so on. So in here we have the vision of the partitions. I have been this from the Sunday. So it has been running on my personal computer and so on. So yeah, you can see the history of the runs, the metadata. So in this case, we have a lot more of metadata here. So we can see how many rows we have download. So this is very similar to my previous example of PIP. And this is downloading some data from online and making it available. In this case, these assets, okay, in here you can see some nice plots about your metadata. For example, in here I'm plotting how many non-empty items, so you can track if something fails, something is strange. Maybe you can also get more fancy and put some statistics here. So yeah, so it's a very useful thing to track your pipeline, the health of your pipeline, as well as some metadata here, so everyone can understand and the dependencies. So we go back to the asset groups and we see the global asset lineage. So in here we have this one that runs every hour because it has partitions associated. It's kind of a schedule. And we have these two assets here that are just PySpark. This in the background is using PySpark to handle the data, to classify that data between what it comes from a story or from a comment. This about news. So yeah, we can have this. And if you notice here, we have asset groups. So in asset groups, you can kind of put together, as I mentioned previously, something that maybe is only data engineer related like this, because it's just getting data from a source and making it available. So that's what we are doing here. In here, we're getting the data through that API. In this case, we are using an IO manager that is going to use Parquet files in my file system to make available these two data sets. And after that data engineer part, we have the data analytics part that is in here. You can use dbt. For example, in this, we have a dbt core. I don't know if you know dbt. dbt is just a framework to work with SQL models. What a model is just a query. I recommend you to check out dbt if you don't know it. It allows you to make very clean code with SQL. So I encourage you to use that if you are using SQL. And the good thing about here is that your models in dbt can be easily be referenced by Dagster and in both ways. So you can, in that dbt model, you can reference an asset from Dagster and as well in the other way around. So you have this here. For this, I will show you the code. For this, you have some different IO managers, so you can have IO managers different from here. So remember that in here we are putting the Parquet files into the file system. In here, we are going to run those models in a DocDB database. If you don't know, DocDB is just a new tool that allows you to query Parquet files in your file system. So that's very nice. And you have another asset group here that is the recommender asset group. So in here we have a machine learning model that is SVD, is a matrix decomposition algorithm. So to get the top comment stories and the top recommender stories. So I have a failure here. So if something that I haven't mentioned is that when you have two assets associated, as soon as the previous asset is being materialized, by materialized I mean to put the data in the Parquet file, in the file system in this case, when that is available, this automatically triggers. So the only one that has a schedule actually is the items here. So this one runs every hour, and after, as soon as this is finished, the other assets will materialize as well. So this is very nice. And now the code. So if you see something that I want to show you really quick is that yes, this seems to be a lot, but actually it's very simple. Something very important about Dagster is the easiness with you can the easy way that it allows you to test in your local machine, to deploy into staging and prod, because having the resources decoupled from your compute, you can say something like this, that when you are in local, you are going to use resource local that it defines your IO manager. For example, if you are working in your local computer, your IO manager, what will do is to get the output of your operation of your assets as a Parquet file in this in these paths, for example. The same one for the asset group for data science, for data analytics. Instead of putting that Parquet file in the file system, is going to do it, but in a DocDB database and so on. For example, if you are not using your local machine, but now you are deploying into an staging environment, by changing only an environment variable, you change everything like it is in here. Instead of putting Parquet files in your file system, you flip to put those Parquet files into an S3 bucket. So you have this IO manager here to handle that. Also, now you are not using a DuckDB database, but instead you are using a Snowflake database. So you can put that here in this database staging. And when you are running in production, you switch your schema in Snowflake, or you switch your bucket in S3, so you can very easily switch between things. So yeah, that's very interesting. Let's see. I haven't showed you how different encode an asset is from an operation. So actually it's pretty the same. So in here we have this function that it just get the data from the API, and using PySpark is going to create a data frame and output that. And this output will be, since we are using this Parquet IO manager, is going to be output as a Parquet file in the file system, if it is that is the configuration. So yeah, you can have that here in that way. So if you see it's the same as an operation as in the first example, the difference here is that now we are kind of linked to a data set in the output. The same for this one. So yeah, it's very clean. So yeah, that's the second example. If we see again here, so I already show you.
Are asking about the repository and the code, if you can share with us later.
For course, of course.
Answer Q&A.
Yes. Yes, of course. This is available in this link. I will share with you at the end on the chat. Something that maybe you will need is, for example, when I run that from that, I had to do some changes from the official documentation. I recommend you to put your Dagster home. The Dagster home is the path where you're, since I'm running this in my local machine, so the Dagster home is a folder where you are going to put all the history of your runs, and the configuration. So that's important. If you don't put it, if you don't establish the Dagster home, it is going to use a temp folder and you will lose everything when you reboot your computer. So maybe that's not good. Also, I was having this bug from PySpark, so I had to add this flag here to make it work. So yeah, I will share this for you. This is the only difference that I have done from the official documentation. But yeah, you can download that from there. So yeah, what else I can show you here? So as I
Danny,
mentioned,
if
we
you
have,
want,
yes.
there are a
Mhm.
few questions. If you want, we can address two on that.
Okay, okay,
Or
give me a second. So yeah, and the declarative conception of Dagster will be great of the record. Thanks for your time. Okay, yes, that's actually a very good mention. Uh, is related to the fact that I showed you here about that in here. The only one that has a partition configuration is the items. So you have a kind of a schedule for the items. But for the other, you have a declarative way that you say that just this data asset depends on this other and no more. That's the declarative aspect of that this one depends of this. And what will that mean? That when the partitions are materialized here, this is going to run. So yeah, that's the point there.
related to the question, there is Alexander
Mhm.
who is asking how are dependencies handled in Dagster. For example, when I have to a condition to pass one process or another. And you mentioned sensor too. I believe that is
Mhm.
related.
Okay,
How
the
depend?
arguments, the
Yeah,
dependencies, the dependency
dependencies and
between
conditions.
operations and conditions.
Yes, I will read again, but how are dependencies handled in Dagster? For example, when I have a condition to pass to one process or another. And
Okay, maybe you don't want, in some cases you want to run an operation and not another one.
yes,
Yes, that's possible. There are some patterns in Dagster. You can have a branch operator. I don't have an example here, but you can have a branch operator. So in a way that at runtime, it will decide which operations are going to run and which not. I haven't seen that behavior in assets. I need to check. Since this is declarative, I don't know if they have kind of a way of saying if this asset is materialized and this another one not, kind of doesn't work. But for this is as these lines mark. So this is going to run as soon as this asset is materialized. The same for this one. But of course, for this one here, you need these three to be materialized. This 1, 2, 3. So yeah, so yeah, that's the declarative way. So yeah, for example, this one has that dependencies from this here and this one here. So yeah, you can establish those kind of dependencies. But a conditional dependency I haven't seen in assets. I need to check, but I definitely know that they exist for operators. So maybe they exist also for assets as well. So yeah,
great.
after that example, I don't know if there are more
There
questions.
are two more. One is
Mhm.
about the usage in Factor, how many people are using Airflow versus Dagster.
Okay,
You
okay.
want to address? Or-
Okay, that's a good question. Actually, within Factor, I think it's the same as in the whole industry. So kind of in Factor, we are kind of a small sample of that. So, and that's about this slide actually. So thank you for that question. So Airflow is the mainly used tool for these kind of things. Even though at the beginning Airflow wasn't kind of happy about people exchanging data between tasks, and now Airflow is different. Airflow has, as I showed you now, they have the assets, they have a new API, maybe not too new, maybe 1 year ago or two. That is the task flow API. You have a lot of things new in Airflow. Maybe not a lot, but new things that are more related with data. So in that regard, a lot of people have been using Airflow inside and outside factor. And Dagster has came up as an, a challenger, as well as Prefect, that's another orchestrator. But I think they are kind of a little bit far away still from Airflow, because Airflow has this advantage of the inertia. A lot of people is using Airflow, a lot of DAGs are in Airflow. Maybe that pressure of kind of you need to rewrite all your DAGs or something like that, and maybe kind of makes the people scared. Also the managers, if they have um, a project, and you know that developers kind of switch jobs very often, so they don't want to that risk of maybe making everything in Dagster. And since few people has worked in Dagster, because there are few projects working on Dagster, and so they kind of are reluctant to that. But now I think I'm more kind of an open mindset about that. I have been here Dagster a lot more, because Airflow address now some of the data challenges that Dagster proposed, for example, with the data set, that the kind of thing. So it's matter of time, I think, if we will see how good Airflow kind of continue catching up with his development. Um, and maybe at some point Dagster has a new feature that is very hard to kind of copy on Airflow, or doing something
Yes.
similar. So yeah, but
Uh,
until then, I think the Airflow will be continue kind of the main standard. But I encourage you to, if you are using Airflow, please use the new features of Airflow for data projects, so your code is cleaner and is better, and you have a better
yeah.
UI and so on. So yeah.
What I can include on that, probably less than 10% of the clients use
Mhm,
Dagsters, but we are
mhm,
seeing a trend like in the industry that there are new clients, or some of them that are experimenting more analytics engineer with the Snowflake, dbt, and Dagster, for example, and as a cleaner stack and more correlated with the modern data stack. We also have other clients that use, for example, orchestration on Databricks, but
mhm.
mainly, as Danny said, are using Airflow. And there is one last question about
Mhm.
testing
Okay,
on Dagster. If you can show an example of that.
of course. Yes, in this project, we have some examples here. Uh, Actually, that's a very good. Thank you for that question, because I forgot to, to talk about the test. And testing is an important aspect of Dagster, because they want to kind of make the developer more productive. And for being productive, you need to test often. So you have a smaller loop when you develop and test, so you catch error faster. So yeah, they have here this folder for tests. They use mainly PyTest. So if I go actually, okay, yes, we can test your pipelines in this way. So you just produce a configuration. So you choose the resources that you are going to run with the tests. And in this example are these. And this allows you to say, for example, you have a resource that is going to being used only with testing. So instead of pointing out to a Snowflake, for example, or AWS, you point to local stack, for example, and you run your test using that environment. So that's very cool, because you can test in your local machine without being afraid of breaking something in production or whatever, or maybe waiting too much because the data is too big. So you can mock up some of the data sets. So for example, they have another test here, and test resources, for example, they have, I'm pretty sure and you can test everything. You can test the IO managers, you can test the operation, you can test the sensors. I have seen where they mock some
Sorry,
data. See, yes, for example,
Danny.
they mock here some data
Okay.
instead of creating a new resource, so they mock that data and they use PyTest to test the assets, for example.
Danny, I think we
Mhm.
have to close because of the time.
Okay.
There
Yes.
is another question on the chat, but we can answer later offline.
Mhm.
Offline. Thanks all for being on the talk. Check the agenda. There are more talks. Dan is talking again tomorrow. You are more than welcome to join us.
Uh-huh. Uh-huh.
And after you can share also the repository the people was asking. And thanks Danny for the talk. It was very
Yes.
interesting. I really
Okay.
enjoyed.
Yes. Thank you. Thank you too much. I just want to, in 1 minute, go to the last slide. There is how Dagster is deployed. What I'm going to mention because of time is that now Dagster has the Dagster Cloud infrastructure, so you can use Dagster Cloud very similar to Astronomer, and they have very cool feature that using GitHub Actions you can deploy your code, and if you are maybe doing a PR, you are going to deploy that in to an staging environment and run all your data there. So your PR will be not only related to your code, but also the data sets that is producing. And to close, uh, is it the prince or not, Dagster? So as already mentioned, there is no king here. There is no prince. We are just using tools in engineering. And as I showed you, everything is evolving. It's kind of a democracy. It's not the best. It's not perfect, but it's the best thing that we have. So yeah, Alpha will continue evolving. Dagster will continue giving some new features. And other tools will keep appearing. And so the objective today was to kind of show you a little bit about Dagster and my purpose here. And I hope that that will pass, that after the end of the meeting, you will go to Google or whatever, and you are going to search for Dagster and you will start playing a little bit with it. So yeah, with that, I finish. So thank you so much for being here.